So now let us talk about some properties of linear system. Okay, properties of linear system. So what are the properties of linear system? Essentially, let us assume that you have two functions. Uh, so basically, the first thing is the principle of superposition, which we already discussed in ODE part, the first part. Okay. So first of all, let's write down a system. Yeah. So let's say capital Y prime equals to AY plus small b. This b is also a vector, yes, that constant part, that part is accommodated here, right? Okay, or a function of x, just a function of x. If you want to, you can just do it here. Okay, now so where A is a 2 cross 2 matrix, okay. Of course, capital Y and B are 2 cross 1 matrix, okay, or vector, whatever you want to call it. So this is up to you anyway. So that's the thing. Yeah. Okay, now see, there is something called a principle of superposition. The first property is this: the principle of superposition, and that holds for homogeneous superposition. Okay, this is for the homogeneous system. Yeah, homogeneous system. So essentially, you guys already have some idea, I think, that if you want to study, see, the way is this. First of all, we want to study the general form of ODE, non-linear system. Okay, because most of the time the ODEs which you encounter in real life are non-linear systems. Okay, but to study non-linear systems are extremely, see, non-linear systems, to put it very softly, is extremely difficult thing to do. Okay, they are highly difficult objects to understand what's going on. So what we do is essentially look at a neighborhood of those systems at some particular points of, let's say, initial data, and we if possible, yeah, we sometimes try and linearize the system, so make it a linear, so make a good approximation of the system, if you just think of it like that. So essentially, okay, we think of a nonlinear system as a linear system locally, clear? Okay, and then we study the linear system. So that is why it is important that we know how to work with linear systems. Okay, so after that you study the linear system. Now once you know the linear system, what you do is what I am trying to say is linear systems are very important, but linear systems are two part. One is a homogeneous, one is a non-homogeneous part. Okay, so first of all, we study the homogeneous part. Okay, homogeneous part. And we already know that once we know the homogeneous part, there are other methods which we can use to study the inhomogeneous or non-homogeneous part. Okay, so this is actually the other way. So first of all, we study the homogeneous linear system, after that inhomogeneous linear system, and from linear then we go to non-linear. Okay, that's the goal. Okay, so for a homogeneous linear system, you see, what is the principle of superposition? So if y1, okay, and y2 are two solutions of one. Okay, now here I go. I don't remember what did I prove solutions. I don't remember. Let's just do it. Yeah? So what's a solution of one? So, and after that I will write. Okay, maybe I will explain to you later. What do I mean by solution? For now, let's just call it there are two solutions. Yeah, and we want to see what's happening. So B is 0, homogeneous. B is 0. So let's say if there are two solutions and alpha is some scalar. So I want to talk about what happens to alpha y1 plus y2. Okay, I want to see that what happens to this particular thing. So you see, let's say that alpha y1 plus y2, let's call it a new function, I don't know, maybe something, how do I put it, z, z, let's call that as z, let z is this. Then I want to see what z prime is, z prime, yeah, z prime, I mean, of course you can, I mean, break it up and see that what is happening, but I don't want to do that part. I mean, essentially you guys can see that that is going to be capital A, okay, times z, clear? If I am defining it like this, then z prime is going to be capital A times z, right? Okay, so I mean, I'm not doing all that, I mean, you guys can do it yourself. So essentially what I'm trying to say is if alpha y1 and y2 are solutions of 1, so that is what I'm trying to say is if y1 and y2 solves 1, then alpha times y1 plus y2 also is a solution of 1, correct? I think it is very easy to see, yeah, for a homogeneous problem, of course, for the homogeneous problem, important, homogeneous problem, of course, this is for homogeneous problem, but there is nothing to see here, I mean, you can just put it together and stuff. Okay, so that is that. And what is so special about this superposition principle, because this actually says that if you write S to be the set of all solutions of 1, set of all solutions, and by solution I will just I mean explain just after this, set of all possible solutions, okay, possible solutions of 1, okay, if S is a set of all possible solutions of 1, then S is a vector field, vector space, okay, vector space over R, okay, vector space over R. Now what sort of vector space is it, that we don't know, we'll look at it later, okay, but for now S is a vector space over R, that's fine. Okay, now let's look at some properties of S. Maybe we can do it later, the properties, we want to do it here. Okay, I will talk about the this thing, solutions, and then we'll move end this video. Okay, so solutions of a system, so this is exactly the sort of thing which you actually understand by a solution. Okay, so let's say you are given this system, whatever it is, linear, non-linear, does not really matter. So let's write down a linear system, non-linear system, right? So y1 prime of x is, let's say, some f1 of x y1 y2, and y2 prime of x is f2 of x y1 y2. Okay, so let's call it 1. So 1, by a solution of 1, let me write it this way, definition phi, capital phi, yeah, so phi is a function of x, and that is given to be y1 and y2. So up till now I was just writing small y, but for now I will just write it as x, x. So phi of x is said to be a solution of 1, if phi prime of x is equals to capital F of x y1 of x y2 of x for all x in I, okay, for all x in I. So essentially what am I saying? I am saying that this two relation must hold for all x in I, okay, along with the fact that phi, okay, along with the fact that phi has to be a C1 function, okay, of I to R2. Clear? So C1 function. So basically, what is a phi? It's essentially, I mean, if you just think about it, it's a curve, right? I mean, it's taking a one variable I to R2, right? So phi has to be continuously differentiable C1 in I to R2. Okay, so that's as your solution. It's a C1 function from I to R2 which satisfies phi prime of x equals to capital F of x, y2, y1, y2. So where with capital F of x, y1 of x, y2 of x is given by f1 of x, y1, y2 and f2 of x, y1, y2. Clear? Where f is given by that. Okay, so that's your definition of solution. Okay, so with this we are going to end this small video.